Okay, today we are recording a session on the third module of our current HCIE Datacom exam version, which is about the basic configuration of a wide area backbone network. What I'm going to demonstrate next primarily involves the central part of the overall topology, which is the area I'm circling with my mouse right now. This includes 6 service provider devices and 6 PE devices. Let me zoom in on the image so everyone can focus on this first. This means that in this diagram, apart from the company's headquarters in City X on the left and a branch in City Y on the right, there's also one of the many nationwide pilot stores at the top and a data center in City Z at the bottom. Currently, apart from the company's basic internet or online business services, they have some special traffic, such as production and R&D operations. They have arranged for a dedicated access to the service provider's wide area backbone network. The main technical points of assessment involved include the underlying ICS intermediate system to intermediate system, BGP border gateway protocol, and MPLS multi-protocol label switching. It will also involve some other technical points, such as BFD, FRR, and we will use VPN instance partitioning here to adjust the direction of the current traffic, the transmission of routes, including dealing with a series of route transmission issues that may arise in the future when introducing and publishing routes. All these are problems that need to be solved in the entire third module assessment item. In the future, when you enter the preparation stage, we will have detailed explanations for each sub-question. These are in the order of the exam questions. Of course, during the exam, time is quite tight, so in addition to answering each question in the order and typing commands according to the requirements, we will also cover a faster method to get through the lab practical. So next I will demonstrate a part of it, which is a display of a configuration method that can be completed more quickly during the exam. Everyone can follow my pace and take a look. Okay, and then what we are going to cover next is not just pure technical explanation. I mainly want to show everyone how to quickly type the solution, including some basic techniques, and introduce a part of it to everyone. Of course, I will introduce a part of the meaning represented by the solution here. Okay, first of all, I have already opened the 6 key devices here, namely XPE1, XPE2, YPE1, YPE2, ZPE1, and ZPE2, middle 6 devices, which are the core devices of our wide area backbone network. As you can see, I have placed a whiteboard or a notepad on the right side of the screen. It is actually a very good tool or a helpful assistant in future exam scenarios. During the process of configuring a large number of devices, you will notice that many configurations within these devices are similar, or they only require some parameter changes before they can be copied directly to other devices. So in the exam, it will help us save a lot of valuable time. In the following command explanation process, I will also try to integrate some replaceable commands and then show you the overall approach we take in the configuration process. I will not explain the meanings of the commands themselves or their technical aspects, as these are things you will fully learn in the future. This time, our explanation and demonstration will only focus on the solution itself. Okay, let's start. First, on the device we need to enable a feature which is BFD. It will be combined with many technologies in the future, such as MPLS and BGP. Apart from that, we enable MPLS passive here. Next, we start configuring the MPLS LSR ID, which is a very critical parameter in MPLS configuration. Since we are configuring XPE1, we need to use its loopback interface address as its LSR ID. Its loopback interface address is 1.0 to 0.1. After entering, we need to configure some MPLS-related content, such as enabling BFD that we just configured in MPLS. Apart from that, it's MPLS BFD settings we need to apply, including setting the detection cycle for MPLS BFD. For the cycle, there will be specific parameters in the future exam, and here I set it to 100, which completes our first part. Besides that, we need to enable MPLS LDP. After turning it on, we move to the ISIS configuration. First, in ISIS, we need to set a corresponding level, and here we choose level 2. Apart from that, we select wide metrics, which are requirements we can extract from the question in the exam. In addition, we associate it with our BFD all interface, and then we write enable. Besides that, in the same way, we need to set a detection cycle. This cycle parameter is actually very crucial for our exam. Okay, here we need to add a small tool. As I mentioned at the beginning, we need to choose FRR binding here. Apart from that, this is a small configuration for the first part. Afterwards, we need to set the network entity for ISIS. How much? 49.00010.00010, which is its basic naming rule. Apart from that, we need to configure authentication. There will be a specified password for the authentication configuration, which is Huawei 123. Besides that, finally, we configure FRR, loop-free alternate, and here we choose level 2. Alright, after we have completed the above steps, we check our basic configuration here. Usually we will verify how many items there are in total. In this part, there are 9 configuration options, so this part is considered complete. In the exam room, when we finally go to compare configurations, how to judge whether the completeness of your work at this step is high. Usually we record how many lines of configuration there should be after completing each section. Everyone should be very sensitive to the number of lines of commands during the typing process. After completing this part, we have actually finished the first part of the overall configuration process. I also want to tell everyone in the exam room, you can configure each device directly in this way. But as I mentioned before, many configurations are repetitive, so actually, in the process of just configuring, you can directly enter each view, and after completing the configuration, use display this to copy down all the configuration content inside that view. For example, let me demonstrate it to everyone again. For instance, after configuring BFD and completing the MPLS passive setup, we can perform the following configuration here. For example, BFD. After entering this, we can check the configuration and copy it, paste it into our notepad. After pasting it, we can continue scrolling up. Below, we just entered the MPLS configuration, so we can enter into the MPLS view. Of course, the best way is to copy and paste directly once everyone has completed this part. As for why we need to do this, I will explain later. Apart from this, if we scroll up, we just entered a command, MPLS LDP, a relatively independent set of commands in this context, which also needs to be copied. Other than that, there's our ISIS configuration. So we enter this, and then use this to copy what we just did. Now the passwords we can see are displayed in encrypted form, but it's okay. In the exam, if we work on this part, we can directly copy it. For the device, as long as all your ciphertext is consistent, it can't determine what characters you entered here. Okay, let's continue. After completing this series of configurations above, we will move on to the next stage. Before entering the next stage, I've placed this image here so everyone can see it. Image here so everyone can see it. Afterward, we'll move on to several interfaces on the device, which include 3 physical interfaces. For instance, ZPE1. What does it connect to? It connects to XCPE1, YPE1, and ZPE2. 3 physical interfaces as well as a loopback interface on the device. Under these 3 interfaces and a loopback interface, we need to configure them. So we can directly type on our notepad here because later we will paste these commands onto our command line. Here we enable ISIS, we turn it on. After enabling it, you can choose not to type this command. It's okay because we will paste everything together later. We enter the interface, the device's interface. The 3 interconnected ports will have interface identifiers in the future exam room, but we will not demonstrate interface identifiers here. I will just directly tell you which interface it is because the interfaces in the exam room might change, but the principle remains the same. We enter its overall interconnected port number 1, and first enable ISIS. After enabling it, we make some corresponding parameter settings here. So why do we need to set each item? Why modify its mode? Later, when explaining according to the questions, we will provide detailed content introductions. IS authentication is definitely something we need to configure. The password here, in the future exam room, all passwords will be Huawei 123. This password is important to remember. Besides, we need to enable sync to align with the current question's requirements, and under the interface, enable MPLS LDP. And finally, we need to adjust the MPLS MTU. We adjust the MTU here to 1382. In the future, in the question requirements, we will actually see this part, why to make such adjustments. Here, I won't spoil the question requirements. Okay, after completing the first interface, we copy this interface because the remaining two physical ports are similar to it. There is one parameter that definitely needs to be deleted directly, such as the address, because each interface's address is different. So when pasting this part of the command, you can count how many lines it has in total. This part, along with the command to enter the interface, totals 10 lines. Therefore, in the end, in the exam room, you can select and check if the number here is 10, which indicates that the configuration for this part is correct. Then we copy it twice here because the configurations for the other two interfaces are basically the same. However, we need to change the interface numbers. The second interface is 002 and the third interface is 603. Alright, after we have corrected these, the remaining parameters do not need any adjustment. The difference with 603 is that it is a cable connecting with the overall PE devices like ZPE1, ZPE2, XP1, XCP2, YP1, YP2, connecting with the devices in the same machine room. Actually, these two PE devices, in terms of their physical location, geographically, they are in the same machine room. Here we do not adjust the MTU. What we adjust here is the ISIS cost. We make the adjustment here, and I'll place it here. This is also highly aligned with the question requirements in the future. Here, everyone can remember, we only need to change this one command to ISIS cost. We set its value to 5. We are configuring in total, which is the current XP1 device. So in the process of overall configuration, what we are adjusting are the parameters of this device. I'll minimize it a bit. Then we start to check again from the very beginning of the BFD configuration, MPLS configuration, then IS configuration, loop back interface configuration, physical interface configuration. These two physical interfaces remain consistent. This physical interface does not need to modify the MTU, just change IS cost. After we have done that, Ctrl+A, then Ctrl+C, copy it to our device and directly paste it on. The previous repetitive configurations, do not worry about them. That's okay. Finally, after we have done that, we can actually add a command to exit, Q. In the future, because we need to execute other configurations, you can actually add a Q here too. This is a habit in the exam room. Alright, after we have completed the first device, the other devices are basically the same in principle. So I have minimized this diagram and placed it here, alright, because otherwise it would obstruct our view. Let's talk about how to configure the other devices, which is the key point next. In the future, during the process of learning technology, technology is very important, but how to save time in the exam room is also very crucial. Our second device is largely consistent with the first one, but there is a difference in that its LSR ID needs to be changed to the second device's loopback interface 2.0.0.2. Let's start checking all the configurations from the beginning. These have no impact. Where do we need to make changes? In terms of the overall IS configuration, we change these 2's here. Okay. I accidentally deleted this decimal point earlier, but after adding it, this part is complete. Loopback interface enables IS, the first physical interface, the second physical interface, the third physical interface. These all remain the same. Just use Ctrl+C, Ctrl+A, then Ctrl+C, and then paste it directly. When pasting, you can directly switch to the next device. It won't affect the pasting on the previous device. Okay, the same goes when we switch to the third device. It also needs to modify only one parameter, which is the current loopback interface address. We need to change the LSRID. Besides that, we change these two numbers to 3. So the third device is also done. Just paste it directly. Now let's start with the fourth device. It's the same process, and I believe everyone has started to grasp the method. For large-scale lab configurations, it's only the first time, that is, when configuring a single device, that you need to clarify the logic. Then you just need to understand its structural composition and the results produced by each command. As long as you are clear about these, the rest will become simpler. Okay, the fourth device also remains consistent, no need for further changes here and here. After changing, we can still copy and paste it directly, okay? There will be some differences when we reach the Z device. The difference lies in the last interconnection interfaces cost for the original XPE1, XPE2, YPE1, YPE2, which is 5. We need to change the last two devices, ZPE1 and ZPE2, to 4, as required by our problem. In the future, when you look at solutions, each sub-question's technical requirements, including project requirements, will be explained. Here, let me demonstrate the configuration first, okay? I've repeated it, okay? Now, let's talk about 5.0.0.5 and then replace these parameters with 5.5 and then select all and paste. For the sixth device, once you're very familiar with it, the process is very fast. You can complete such a segment in about 3 to 4 minutes, which can greatly reduce your time in the exam hall. Okay, let's copy this as well and paste it onto the sixth device. So, with this, the first part is actually completed. After completion, we can choose to configure some VPN instance on the corresponding devices. Many logs popped up here due to BFD. Let me explain a point here about the future in the exam room. Different racks will have some differences in setting BFD parameters. Some devices can adjust the BFD parameters lower, but if they are too low on some devices, it will cause flappings. This needs to be judged based on the actual feedback parameters after you execute the commands in the exam room. We currently have multiple sets of racks, and the overall feedback from each set sometimes keeps highly consistent with the exam room, so this is also a point to test everyone's mentality during practice, because the exam room is actually a test of mentality. Okay, so this is the part we have discussed. Next, we move on to the second segment. What is the second segment about? As I mentioned earlier, everyone can continue configuring according to the problem requirements. However, due to some routing policy configurations involved later, we generally choose to configure all routing policies in this segment beforehand to facilitate later use without having to constantly switch views, modes, or windows. Here, I will talk about a configuration requirement in the exam room. That is, we define all assessment items and routing policy points of the entire third section here. We will complete all of them, regardless of whether they will be used now. We will complete them here because we ensure that each experimental configuration step is coherent, or within each part. You need to remember all related configurations. Okay, let's start configuring here. First, I will briefly take one site, explain the purpose of this strategy. For example, in the future, we will connect to our headquarters in X city, the park in Y city, our branch, and the data center in Z city. There are actually 2 paths to each, and often there is a preferred path, meaning we have a primary and a backup path. Here, we will control the overall traffic direction through the transmission of MTU. We need to configure routing policies for devices that require MTU adjustment. For instance, we define a route policy here. How much do we write? One of the parameter adjustments is med10, so we name it med10 permit node 10. After configuring, we apply cost add cost of 10 to it. Alright, directly display this, and you can copy this command. I can tell you which devices need this command. In total, 5 devices need it. XPE1, YPE1, YPE2, ZPE1, ZPE2. So paste it directly onto these devices. We accidentally copied an extra space earlier, so they can press enter directly. Okay, this basic configuration is now complete. After completion, XPE2, YPE1, YPE2, ZPE1, ZPE2, these 5 devices need a policy about MED20. So we define root policy MED20 permit node 10 here. We apply a cost of 20, display this, copy it, and then paste it directly onto these devices. This ensures that we quickly apply these policies, that is, define them. It's a real test of everyone's ability to grasp the rhythm of the entire experimental process, which is very important in the exam room. In addition, XPE1, XPE2, YPE1, YPE2, these 4 devices will also need to configure the VPN FRR function. So we write another route policy here. What do we write? We write VPN for R, VPN FRR, then define permit node 10. Afterwards, we apply it, and in the future, we need to have a back TP, a corresponding next hop. For the next hop, we set it to auto, letting it choose in the future. So we paste it there. Okay. Thus far, in the WAN part, all routing policies that need to be configured on all devices should be completed in this part. After completion, it involves dividing the VPN instance we currently talk about.